Greetings. So let's get started with today's class. So a quick recap of what we did yesterday. So we were looking at the components in a typical 4-stroke engine. So yesterday we looked at the piston assembly, and then we learned how it's connected to the crankshaft, and then we also looked at the cylinder head, because in a 4-stroke engine the cylinder head contains the valve assembly, which consists of intake and exhaust valves for letting air into the cylinder and taking out exhaust gases from the cylinder after combustion. So we looked at the intake manifold and the exhaust manifold, which are nothing but mechanisms that aid in this process, and we also looked at the valve assembly, which in most automobiles like is a spring return valve, wherein a dual coil spring is used to close the valve once the corresponding process is completed, either the intake or the exhaust process. Okay. So we looked at what was called as valve float, which happens in typical spring return valves at high speeds, and how it can be minimized, and how one could eliminate it by using a Desmodromic valve. So that's where we stopped yesterday. Let's start today's session by first looking at the camshaft. So the camshaft is also a component which is typically installed in the cylinder head. So the main function of the camshaft is that, like, it actuates the either the intake valve, which I am calling it as IV, or the exhaust valve as appropriate, okay, at a particular cylinder. So as the name indicates, the camshaft is nothing but a shaft which is placed above the valve assembly in the cylinder head, and it consists of all these cam lobes, right. So I am sure all of us know what a cam follower mechanism is. So the cam lobes essentially determine when a particular valve stem is going to be pushed downward to create an opening either in the inlet valve or the exhaust valve. And as the cam lobe rotates with the rotation of the camshaft, the contact may be taken away and the valve will close, right, as appropriate. So that is the function of a camshaft. In a typical 4-stroke engine, the inlet valve and the exhaust valve need to be open once in every 2 revolutions of the crankshaft, okay, because as we learned by what is called as a 4-stroke engine, in a 4-stroke engine, one operating cycle of the engine is completed in 2 revolutions of the crankshaft. That corresponds to 4 strokes of the piston, right. So in one cycle I need the inlet valve to open once and the exhaust valve to open once, right. So in other words, each valve should be opened once in every 2 revolutions of the crankshaft. So this implies that the camshaft should rotate at half the speed of the crankshaft. Correct. So that is when you will have exactly one rotation of the camshaft for every operating cycle of the engine, right. So that is what will happen, right, with this camshaft. Now how is this camshaft rotated? Obviously the camshaft is rotated by the energy that is provided by the crankshaft, okay. So the camshaft is driven by the crankshaft, And how is it driven? So, typically the camshaft is connected to the the camshaft is connected to the crankshaft by means of what are called as timing belts or gears. So, one can use what is called as a timing belt or a timing gear. Okay. So, to essentially get this functionality. Okay. So, let us say this is the camshaft. So, what happens with a timing belt is that, like, timing belt is a belt which has these grooves. It is just like a gear tooth, but then like it is flexible, right. So, this is the timing belt. So, you can see that this timing belt is wrapped around the camshaft, because the main issue with the traditional belt mechanism, belt driven mechanism, is that it can have slip, and we do not want slip when we drive the camshaft using a crankshaft, right, because the timing of the opening and closure of the inlet and exhaust valves will get affected. So, in order to address that issue, we use this timing belt which have these projections to ensure that the the camshaft is rotated relative to crankshaft fairly accurately. Of course, a belt is used if the spacing between the camshaft and the crankshaft is large. In some cases, the camshaft may be closer to the crankshaft and people may use a gear assembly. Okay. But please note that either way there needs to be a reduction in the speed, that is the camshaft needs to rotate at half the speed of the crankshaft, okay, in a typical 4-stroke engine. Okay. So, that is the camshaft. It is placed in the cylinder head and supported by bearings, obviously, because even if the crankshaft is rotating at 3000 rpm, the camshaft will rotate at 1500 rpm, and it is going to continuously actuate many valves in a multi-cylinder engine, right, over a period of over the time interval of one revolution of the camshaft. So, it needs structural support also. It is supported by bearings. Okay. So, that is the role of a camshaft. What about other components in an engine? Like we will look at them as we go along. So, these are some of the main components. Some other components which we would also discuss as we go along. One would be what is called as a flywheel. Okay. A flywheel is nothing but a mass which is attached to the output of the crankshaft. The crankshaft is the link which comes out of the engine, and it provides the tractive effort to drive the wheels and propel the vehicle. So, a flywheel is typically attached to the end of the crankshaft to ensure that any torque fluctuations due to the combustion process are smoothened out, right. So, we will see why that happens as we discuss a 4-stroke engine. Okay. So, the flywheel is essentially used to smoothen out torque fluctuations, like so. That is one primary purpose of the flywheel. Okay. Then what are a few other components? We have a spark plug in a spark ignition engine or a petrol engine that provides a high voltage spark. Okay. The purpose of a spark plug is to essentially provide a high voltage spark, and that will ignite the fuel air mixture and initiate the combustion process. That is the function of a spark plug. And in diesel engines or compression ignition engines, there are elements called fuel injectors that will spray diesel into the combustion chamber at the appropriate time. Okay. So, that is the function of a fuel injector. Okay. So, these are some other components that we would be encountering, okay, as we go along in this discussion. Okay. So, now moving on from components, let us look at the operation of a typical 4-stroke spark ignition engine. Okay. So, let us look at how it operates. Okay. What are the 4 strokes and what is the principle of operation? So, this is just a very simple schematic that illustrates one cylinder in a 4-stroke spark ignition engine. So, this is the inlet valve or the intake valve. Okay. IV stands for the inlet or the intake valve. EV stands for the exhaust valve in this context. This is the spark plug, and of course, this is the piston, this is the combustion chamber where the fuel air mixture is burnt and essentially the process of combustion and energy transfer takes place. This is the connecting rod. This element is the crankshaft. Okay. This is the crankcase. So, these are the typical elements in a 4-stroke engine. Okay. 4-stroke spark ignition engine. So, what happens in a 4-stroke spark ignition engine is that typically either air or fuel air mixture is taken into the combustion chamber, okay, and then the fuel air mixture is compressed to high pressures and temperatures. At the end of the compression process, a high voltage spark is provided to initiate the combustion of the fuel air mixture. And once the fuel air mixture combusts, we are going to generate thermal energy that is going to result in high pressure gases which are going to expand and push the piston down, and that is where the energy transfer takes place, and then the burnt gases which are the products of combustion are pushed out through the exhaust valve. So, those are the typical strokes that happen in a 4-stroke spark ignition engine. Okay. So, what are the 4 strokes? The first stroke is what is called as a suction stroke. The second one is the compression stroke. The third stroke is what is called as a power stroke or the expansion stroke. And the fourth one is the exhaust stroke. So, all these 4 strokes put together contribute one cycle, one operating cycle in a spark ignition engine. Okay. So, these are that is why it is called as a 4-stroke engine. Okay. So, this keeps on repeating and the engine continues to operate. Okay. Now, you can we can observe that in a spark ignition engine or a petrol engine, a spark plug is provided to initiate the combustion process. In a diesel engine or a compression ignition engine, the spark plug will not be present and we will have what is called as a fuel injector, which will spray the fuel into the combustion chamber. Okay. We will look at the differences shortly. Okay. So, these are the 4 strokes, and when the piston goes through these 4 strokes, we complete one cycle. If you look at this, I am just approximately marking the top dead center. We will shortly see what is called as the top dead center and the bottom dead center. So, the piston moves between these two limits, right. So, in the cylinder, okay, or the combustion chamber. Okay. So, before we go and look at these 4 strokes in detail, I am just going to write down a few definitions. concerned with what to say engines, IC engines. Okay. So, the first one is what is called as a cylinder bore. Okay. Let me indicate it by a parameter d. Okay. This is the nominal inner diameter of the cylinder or the combustion chamber. Okay. So, the cylinder bore is nothing but the nominal inner diameter of the combustion chamber or the cylinder. Okay. So, then the piston area is nothing but the area of a circle whose diameter is the cylinder bore. Okay. So, or in other words it is going to be pi by 4 d square. Okay. So, that is the piston area. The third term that we are going to look at is what is called as the stroke of the piston. Okay. Let me indicate it by the parameter L. The piston stroke or stroke of the piston is the nominal distance travelled by the piston between two successive reversals in its direction of motion. So, because the piston's direction of motion keeps on changing and the stroke L is the distance travelled by the piston between two successive reversals in its direction of motion. Okay, that is the stroke L. Okay. So, this is connected to what is called as a dead center. So, what is a dead center? So, position of the piston when it reverses its direction of motion. Okay, that is what is called as a dead center. Okay. So, just going back to this diagram. So, you see that the piston is going to move up and down. Okay. The nominal distance moved by the piston between two successive reversals of its motion is L, okay, the stroke L. So, in this diagram we are yet to define TDC and BDC, but then like this distance will be the stroke L, and dead center is the position where the piston reverses its direction of motion, because for example if the piston is moving up, it reaches the top dead center, it is going to reverse its direction of motion and start moving down, right, and vice versa at the bottom. So, those are what are called dead centers. So, we are now going to define what is called as the top dead center, okay, abbreviated as TDC. Okay. TDC is the position of the piston when it is farthest, when it is the farthest from the crankshaft. So, that is what is called as the top dead center. Okay. The bottom dead center or what is called as BDC is the position of the piston when it is nearest to the crankshaft. Okay. So, that is the definition of TDC and BDC, okay, and that is very obvious from the schematic, right. So, just going to the schematic, you can see that when the piston is at TDC, it is the farthest from the crankshaft. This is the crankshaft, right, and when it is at the bottom dead center, it is closest to the crankshaft. Okay. So, that is the definition of TDC and BDC. Okay. So, the next set of definitions, the next term that we are going to look at is what is called as the displacement or swept volume, which is indicated by V subscript S. So, what is this displacement or swept volume? It is the nominal volume swept by the piston as it travels from TDC to BDC. Okay. So, that is a definition of the swept volume. Okay. So, we can immediately observe that the swept volume Vs is going to be pi by 4 d squared L, right. It is a cylindrical volume, right. So, that is the swept volume. Building on this, we define something called as the engine capacity or the cubic capacity of the engine. What is this? Okay. The engine capacity or cubic capacity is the sum of the displacement volume of all the cylinders. Okay. So, that is the engine capacity or the cubic capacity. Of course, if you have a single cylinder engine, it is just what it is, right. If you have a multi-cylinder engine, you need to add the sum of the displacement volumes of each cylinder. So, let us say if I say I have an engine in a car with a capacity of 1.2 liters and that is a 4-cylinder engine, I can pretty much say on an average, like the displacement volume of each cylinder is going to be 300 cc, right, 1100 cc divided by 4 cylinders. On an average, the nominal displacement volume is going to be 300 cc. So, that is what I can say. Okay. That's the number which we encounter, right, when we look at engine specifications. Okay. So, then there is something called as the clearance volume Vc. What is this clearance volume Vc? It is the nominal volume of the combustion chamber when the piston is at TDC. So, when the piston has reached up to the top dead center, there is some volume between the cylinder head surface and the piston, right. That volume is what is called as a clearance volume. Okay. So, for example, we will shortly realize that when we are doing what is called as a compression stroke, we will have highly pressurized fuel air mixture in that clearance volume. Okay. So, that is the clearance volume. Building on this, we define one more parameter which is extremely important for engines, is what is called as a compression ratio, which is denoted by the symbol R. So, what is the compression ratio? It is nothing but ratio of the cylinder volume at BDC, okay, which is indicated as V subscript T to the clearance volume. Okay, so that is the compression ratio. Okay. So, some people call it as total volume V subscript T, that is when the cylinder is at the bottom dead center, whatever is the volume of the cylinder, that is what is called as a total volume. Okay. That is the reason why we are using a subscript T. Okay, there. So, R is defined as the volume at the bottom dead center divided by the volume at the top dead center. So, we can immediately observe that the volume at the bottom dead center, I can rewrite it as Vc, which is the clearance volume plus the swept volume, right, and the volume at the top dead center is anyway V subscript C. So, based on this we can immediately observe that the compression ratio can be written as 1 plus Vs divided by Vc. Okay. So, that is the definition of compression ratio. Okay. So, compression ratio is going to be a very important parameter, okay, like as far as engine performance is concerned, and we will see that what influence or impact it has on engine efficiency and fuel consumption and energy output and so on, okay, when we do engine analysis. Okay. And depending on the type of engine, whether spark ignition or compression ignition engines, there are typical ranges of compression ratios. See, for example, in SI engines R is typically between 6 and 10, okay. In CI engines it is typically like anywhere from let us say 12 to 20, right. So, it is a typical range, okay, of the values of compression ratios. Okay. So, by and large the compression ratio in diesel engines is higher than in petrol engines. We will see why, okay, as we go along.